And welcome to today's presentation, Edge Virtualization Near-Term Deployment Drivers for 5G Service Enablement. I am the Principal Analyst at Layne Bridge & Associates, and I'm going to be serving as today's moderator and a bit of a presenter today as well. So just a couple of housekeeping notes before we get started. Today's slides will be made available to everyone, so rest assured that after the presentation is over, you will have access to download the slides and view them at your leisure. And as well, you'll notice a Q&A widget at the bottom of your screen. So what we'll ask is, if a question comes to mind as we go through the presentation, please don't hesitate to enter it into the widget. We're not going to answer questions as we go through the presentation material itself, but we have reserved about 15 minutes at the end of the session to address questions and answers. And so, as I mentioned, as a question comes to mind as we're going through the presentation, don't hesitate to enter the question into the widget. If we don't somehow get a chance to answer the question live today, we will follow up via email. So one way or the other, you should have an answer to your question. And with that, I think we'll just dive right in and get started. So just briefly by way of an agenda, again, I'm Jason Marcheck. We'll allow our other speakers to introduce themselves in a second here. But the way we're going to structure this is, as an analyst, and I think, and John can attest, as a technologist for a technology company, these are some of the questions that we get asked frequently. And so we decided to structure today's presentation around, some frequently asked questions that we tend to get asked when we're discussing edge virtualization. So you can read those there. That's going to be the structure of the presentation. And then obviously we'll go through Q&A at the end. So again, my name is Jason Marcheck. I am the Principal Analyst at Layne Bridge. And so you know a little bit about me, but I'm going to give John a minute or so to introduce himself, and then we'll dive into the presentation. So John, you want to let everybody know who you are?
Yeah, good afternoon, everybody. This is John Baker. I'm the SVP of Business Development for Mavenir, really focused at the access side of the products in terms of Cloud RAN, EPC, Edge Virtualization. Mavenir is one of the leading suppliers of virtualized infrastructure for the mobile community, serving about 250, 300 customers on a global basis. So, the majority of that deployment is virtualized software. So a lot of experience in deploying virtualized networks.
All right, excellent. Thank you, John. We'll look forward to hearing from you in a second here. But in the meantime, I'll just jump in with our, kind of one of the questions is, there's virtualization going on throughout the network, be it at the access, the edge, the core. And so there is, I've seen, some questions, at least in my interactions with the industry, is there a difference? Is there different things going on with respect to virtualizing at the edge as opposed to the core, as opposed to maybe the RAN or the access? And, I would say that by and large, a lot of the fundamental benefits of virtualization convey, whether you're talking about telecom networking, whether you're talking about enterprise networking. And I think a lot of those, for those of us who have been in the industry for a while, the scale in, scale out capabilities to be agile in order to turn up services, tear them down, and adjust capacity to whatever particular service you're trying to deliver. I think that is certainly something that's trying to be accomplished at the edge. Somewhat self-evidently, the move from physical networking elements to virtualized networking elements, and really the software development models that go along with that. So not only the ability to run on white box equipment and tap into kind of an open source ecosystem, but also moving from kind of a waterfall development model to more agile models in order to be able to turn up services more quickly. I think where some difference comes in, or at least some nuances, that I think the edge is going to be a place where there's going to have a very profound shift in the way that networks are built and architected when we move from a physical environment to a virtual environment. And here, I would say that, this is really where concepts like multi-edge access compute, where network slicing are going to take place and enable things like local traffic breakout and some other interesting applications. So I really do believe that, this is a fundamental area of where virtualization is going to make a profound impact on the ability of service providers to kind of evolve their service offerings and meet, some service requirements as we go forward. And this is one of the reasons why RCR Wireless has made it a point to to produce a series of research on these topics. So, now we're talking about edge virtualization. In their report library, you can also go and find kind of the drill downs on some of the things we're talking about today. So a drill down on MEC, a drill down on network slicing, and all of these reports are available for free download in the RCR report library. So I certainly encourage anyone who's interested to go there and avail themselves of that option. If we move on to, kind of the second slide we have, or the second question, and ever since, at least I've been following the kind of the 2G migration to 3G, 3G to 4G, there's been this sense of, it has to be about more than just bigger, stronger, faster networks. It really has to be about enabling new services to justify the investments in this technology. And I think what is kind of shaped up, at least with 3G and to an extent 4G, it kind of has been about building bigger, stronger, faster networks. I believe that as we move into the 5G era, we really are going to see a pronounced focus on the ability to support new service types, and some of that is, we talk about killer apps. Bandwidth kind of was the killer app for 3G. In many cases, it still is for 4G. When we're talking about 5G, there's really a sense that there's not so much a killer app as just a ecosystem of relatively unique requirements that have to be supported to support a myriad of use cases. And so if we think about things that are coming down the road as far as enhanced mobile broadband and the ability to deal with personalized video content, and so not so much the Netflix of the world, but say like Snapchat, where users are actually modifying video content and sending it back and forth to one another. So there's certainly some sophisticated networking requirements there. AR and VR comes to mind. The shift in general from today's business processes to digital practices that kind of encompass the Industry 4.0 movement. Ultra low latency is absolutely a facet that I think is going to drive, really hinge upon the ability to execute on business cases such as, autonomous driving and things that we hear about with respect to that, and factory automation. Definitely the need for machines that are operating, a system of machines that are operating to operate at near no latency to ensure safety on the factory floor and things of that nature. And then perhaps on the other side of the scale, not necessarily the enhanced mobile broadband or ultra low latency, but just the ability to support thousands of devices in any given square meter, all of which, or many of which, are going to have different connectivity requirements, different QoS requirements, and different ways that they interact with the network. And so I think that, as we look at edge virtualization and what is driving the need of operators to virtualize their networks at the edge, I think as we move forward, it really is going to be about, not just the bigger, stronger, faster network, but also the more agile network to support all these use cases that aren't necessarily one killer app, but just an ecosystem of hundreds, if not more, killer apps. And, if we move on to the next slide here, what I just said, notwithstanding with respect to the need to support the future, there's also, as we build out networks, there's always a sense of, it's good to keep an eye on the horizon and make sure we're preparing for the future. But at the same time, these are big investments, and these big investments require near-term ROI and compelling business cases, today in order to make these investments worth the money that we're spending on them. And so in that regard, we're quite lucky to have John on the panel today, because he's going to spend some time right now going through what Mavenir is doing essentially to help make the case for edge virtualization today, as opposed to just purely a topic that we need to be thinking about in terms of 5G. So with that, John, I'll turn it over to you and allow you to walk us through a little bit about what Mavenir is doing.
Yeah, thanks, Jason. So yeah, let me start off with sort of just a general, overview in sense of what we see going on, in the ecosystem, and there's sort of many moving points here that are starting to come together as as operators start to look at rolling out 5G. We've seen historically that operators have been building networks, very much centralized architectures, etc. And very much custom hardware, and walled gardens around a lot of the interfaces. Clearly, as we see going on in the industry, as operators try and start to become profitable, you're sort of really trying to address, the business models of how networks are deployed, how networks are operated, etc. And, over about two to 3 years ago, started, I think, with the AT&T, Domain 2.0 rollout of virtualized networks, really started a lot of big initiatives in the industry about how to open some of these interfaces, how to deploy, software into the core of the network and change some of the paradigms that have been around for the last 15 to 20 years. And this is really where Mavenir has been really focused in terms of virtualizing all the elements of the network, starting with the IMS platforms, and now sort of really focused at the edge in terms of Cloud RAN, EPC, and the various transport parts of the network. So there's some of the subjects I'll be touching on, and really working through the business analysis of how to potentially make this pay today rather than waiting for the dream of 5G to come along. Just in terms of the terminology, I'm going to be talking about what we call a media breakout controller. In a sense, it's an application that sits at the edge, very much using the standardized components of the network, and then how that's related to what's known in the standards world as a CUPS architecture, centralized, control plane, user plane, split in terms of the EPC functionality. So just a brief introduction there. So next, go to the next slide. So the challenges, as most of us know, bandwidth is continuing to grow exponentially in terms of people's usage in the network, and that's really sort of becoming a challenge because a lot of the content that users are already putting across the network is essentially applications where operators don't make money. So the challenge there is how to build this network to support these applications that are coming along for 4G, and then in 5G we've talked about these low latency applications in terms of IoT, telesurgery, industrial automation, and local offload, sort of really hot subjects in the industry. But it really comes back to how do we make money out of doing this, and how do I architect the network for supporting those types of an application. I touched on the fact that a lot of the applications that are coming across the network are essentially termed over-the-top applications, where the carriers building the infrastructure, the end user obviously from a phone perspective is getting some great applications coming across, but there's very little money being made in terms of the transport of those applications. So how do networks continue to evolve, put new investments in there, with those types of business models that are still floating around. The third point here really is that there's also a strong move to become profitable today and start to architect the networks, and in that sense of the word, not necessarily waiting for 5G to evolve. The strategy is very much building the infrastructure today that will support software upgrades, feature upgrades to take you into 5G, and having the lowest cost platform that you can get out there today. And then really sort of how do you do all of this with leveraging current radio, current core technologies, and with respect to the lowest TCO. So if you see on the right hand side of this chart, you can sort of bring the edge really back to the RAN, packet core, and services. And I think what's driving this is I sort of draw the analogy to what happened to the IBM mainframe back in the early years of desktop computing. That everything moved from the center to the edge with desktop computing, and I think you're seeing that now, that sort of revolution sort of going on in the mobile telecommunication space. So this is sort of driving some of the thinking that a lot of the compute companies, and Mavenir really has, in terms of its strategy. So move to the next slide. As I say, and you read this in the headlines of, over the last 6 months, I think in terms of the operating community, I think we've seen over 40,000 job losses going on in the industry as operators try to restructure their business plans to cope with sort of declining ARPUS, and prepare themselves for a future of investment in 5G type technologies or high bandwidth type technologies, and the necessary capital investment that that's sort of take to put into place. So we see operators sort of starting to position themselves for how to handle the projected data volumes. And as I say, we've seen projections where operators are sort of looking at this doubling year on year as some of these higher bandwidth applications start to go into place. Latency is obviously key to some of these discussions, and not only for medical type, but just gaming. I think anybody who's got any children, sort of sons and daughters, trying to have low latency gaming sessions, sort of becoming part of the equation. So how do you architect a network, not only for 5G but for 4G with low latency type architectures? The key third bullet point there, profitability is what it's all about. And I think I've been fairly vocal about this subject, that this operating segment should be a segment that's growing, not a segment that's declining. And what we've got going on is operators having to support essentially unsupportable business models or unsupportable models of deploying networks because of what's gone on in the past. In that respect, it's how to maximize the investment that's obviously gone in place. Clearly you can't tear up a network and throw it away. It's got a 5-10 year life cycle with some of the equipment out there, and networks have been built in the way that they've been built for for reliability and initial introduction of services, etc. But there's a lot of things in those networks, as a mix of GTP traffic versus IP traffic that are causing expense in the network. And then the EPC, the evolved packet core in the 4G world, which is essentially everything sort of really passing through the packet core, and that's where some of the major expenses is being seen. And then how to migrate services, and continue to provide the necessary services such as lawful intercept and monitoring services. Key in terms of operators providing quality of service in their networks. And once you start to say, well, okay, I'm going to take my core, I'm going to disaggregate it. How do some of these services start to roll out towards the edge, and you can maintain these legal services and other services that are currently being provided. Okay, next slide. So I've got a couple of slides in here, looking at typical network architectures, and if you look at the right hand side first, in terms of how typical networks are built, typically they're built on fiber rings if possible, where BTS sites are hubbed into fiber rings. That sort of gives a level of resiliency in terms of the transmission to the base stations, and then that transmission is concentrated back into the EPCs and out through signaling gateways, etc., in terms of the IP traffic. So you've got this sort of north to south signaling going on, where the level between the base station and the EPC is essentially GTP traffic, which again is obviously a GSM or 3GPP protocol stack that's interacting across the elements, and that in itself is a separate path, if you like, from the IP traffic, and giving a rise to other expenses in the network just in terms of handling that GTP traffic. But the key points here is that typically all the data is passing via the EPC core in the network, both in and out of the network. And typically what you find is that operators today only have a few offload points, and obviously a lot of this is done in terms of putting walls around for security purposes, in terms of firewalls. Having fewer points of offload because at the time that was where the best way to do it. But practices have evolved. The web's moving extremely fast in terms of its build out, and so points of presence now can be looked at. But again, it's about dynamically managing the design of the network as you go through this day to day. The other key point, and this is probably the most important point that comes out of this, is that if you take the statistics of the traffic that are flowing across a mobile operator's network today, you'll see that 80% of that traffic is actually video traffic. And we just did a recent analysis for an operator, and in fact, in terms of that 80%, 10 discrete services actually took 75% of that number, and so you get to a point of saying things like Facebook, Snapchat, and those other video services like Netflix, etc. Really are dominating the traffic that's flowing across a mobile operator's network. And the other important part of that is 40% of that traffic is actually encrypted. So what you get to a point is with the encrypted traffic, there's very little a carrier can actually go and do about that in terms of controlling it or making money out of actually handling that traffic. So and we'll show in a business case later on that if I could just do something about that 40% encrypted traffic, I could save considerable investments in the network and actually fund the deployment of edge services. And I think that's one of the key points that we'll come to in the later slides, that I can actually fund the deployment of edge services and not have to be sitting around trying to justify which 5G service is going to make me money. I can put out edge infrastructure and have it pay today just by looking at sort of re-architecting how some of the traffic flows through my network. So really, it's about changing the network business model, changing the network architecture, and sort of analyzing a lot of the additional 3GPP costs, as I would call it, in terms of how these networks are built. I think that's the next slide. So I think everybody sort of has built networks really sort of understands the sort of the hierarchical structure north to south of a network, in the sense that you see all the RAN connectivity connected out to the B sites, small cells, etc. But essentially everything is coming back from the edge right way through to the back end of the network where the EPCs are actually located, and that's where typically the offload is being done. If we go to the next slide, we see where in actual fact, if I could put some sort of breakout element closer to the eNode Bs, and obviously arrange the firewalls, etc., sort of for the protection of the network, I can start offloading traffic before it actually hits that EPC function. And typically if you look at the cost of maintaining a customer, 20-30% of that cost is actually sort of license charges for EPC connectivity, etc. So you've many ways to sort of break into the transport network of a transmission network and look at different ways of offloading it, and this sort of starts to say, look, if I can sort of take some of that EPC functionality, push it towards the edge as part of an edge application deployment, then I can start to look at other ways to break my traffic out of the network. And it may be that one example is just just converting everything to IP and then just using IP traffic. And if we go to the next slide, this slide is sort of a little bit complicated, and apologies for that. It's if we look at the elements of the transmission, before offloading or before considering about moving the architecture to the edge, on the left-hand side, you can see, you've got these, BTS hubbing rings, as I would call it. The blue circle on there is essentially to represent the form of traffic, and obviously there's a lot of high concentration of GTP traffic from the base station back into the EPC essentially. And the red line is the sort of concentration of IP traffic. There's some IP traffic coming out of the cell sites right the way back to the core for O&M and stuff like that. But it's only really when you get to the EPC do you start to then on the north side of the EPC you sort of break it out and it becomes IP traffic, which sort of goes out into the signaling gateway. So traffic flow sort of top to bottom here, and very high concentration of GTP traffic versus IP traffic. If you then start to sort of move the elements to the edge and start to do the conversions, such as you convert traffic in the hubbing, the transmission concentration ring, then you can move that traffic from essentially IP traffic to GTP traffic to IP traffic, and then at that point there, then you can break out into the outside world, which is obviously IP based. So you start to look at, okay, how can I get hubbing points closer to where some of these nodes will actually be, and yeah, there's potentially there is concern about numbers of hubbing nodes and the security around those hubbing nodes, etc. But again, this is technology that the web world is well versed to today, and there's no reason why it's not being adopted in the mobile space. And then you see the very high concentration of IP traffic in around the hubbing nodes, and reducing the traffic effectively on the EPCs, and then obviously allowing the investment around the EPCs to to be optimized and getting more value out of what those EPCs are doing. So really, how do we do this? So if you go to the next slide, what as Mavenir, what we've been sort of looking at and working with carriers on is sort of putting what we call an EPC media breakout. And the reason for the media breakout definition is really coming from the fact that 80% of the traffic in the mobile network is video, and so if you just focus on just the video piece alone, you're going to make significant improvements in cost reduction in profitability for the mobile operator. So in that sense, you want the transmission, the user plane transmission, if you like, you can break out, but the control plane, you still want to handle in terms of security, etc., going back through your normal EPCs. So this really sort of starts to introduce one of the specification parts that was sort of introduced in 3GPP back in mid 2017, that looked at breaking the EPC functionality essentially into two parts, where you could scale the user plane of the EPC separately from the control plane, and this sort of allows you to essentially scale or reduce in scale, depending on the architecture, the user plane part of the EPC. The other key part of this is that from a security services and registration part of it, the mobility management part of it, really you still got to maintain back in the core effectively in terms of the control plane part of the EPC. What this actually does for you is sort of minimizes the GTP transport network, and again, you can sort of minimize the investment in that GTP transport, and then sort of put together the IP parts of the network together on the separate transport mechanisms. But at the end of the day, I think you could argue that the total bandwidth being carried within the network is the same. It's just which protocols are being used to carry that bandwidth, and how you make more of a seamless transmission into the IP world, or the web world, as we call it, as you start to move towards web scale type services. So, in the sense that, making use of these hubbing locations for, doing this control plane, user plane split. We show it here as a hubbing location, but actually I could push that right out to the cell site, in terms of compute functionality and start right at the cell site if there's the ability to break out there as well. Next slide. So why control user plane split? And this technology is available today, and this is, you can do this without waiting for 5G. You can use it for reducing latency of an application as a service, and by moving the user plane part essentially close to the cell site or where the end users could be. And this could be sort of not only in a macro network, it could be used in an enterprise network in terms of breaking out traffic within the enterprise back into the local enterprise network rather than transporting it back out into the core. So the CUPS architecture, if you like, for an EPC allows a lot more flexibility in the network and how you break it out. The fact that I can scale my user plane and control plane separately means that I can sort of look at the investment on a service type application rather than having to scale the whole platform to support both as a combined user plane and control plane. And that's typically much what's going on today is a lot of investment obviously going in to support this growth of data traffic, without any revenue sort of being attached by it. So scaling the CP and UP resources independently is probably the key technology function here. But again, this is all sort of coming out as open standards and available to do it today. So you can use software-defined networking in terms of control of the user planes, and what this allows you to do is maintain a full EPC media service at the edge. And this actually then starts to fall into the fact that now I can do this at the edge. I can actually now justify the provisioning and the investment of putting these edge servers in place, which then I can actually then run additional services on, and I'll touch on that in the next slide. So we go to the next slide. So this is a drawing straight out of 3GPP specs, and no apologies for this. It highlights the two main points here. That in the center there, there's the definition of one new interface, the SX interface, and this sort of allows the coordination of these multiplicity of user plane platforms that are being put in the network. But everything else in terms of control, policy services, etc., and all the other interfaces are identical to has been defined in EPC, in 3GPP. So by putting this type of a split EPC functionality out into the network is allowing obviously the split and growth of the user plane on the bottom of this drawing, and minimizing the numbers of new interfaces. So you can continue to use the same investment in O&M and policy servers, etc. Around the whole architecture. The other important point, which sort of gets, I think, has been missed, and this is somewhat getting caught up in this mobile edge compute discussion that's that's been going on for a while in terms of where is the edge, what is the edge, and what services can I run at the edge. On this far right hand side of the drawing, you'll see there's this what they call this SGI interface, and essentially that's everything at that point is passed back and becomes IP, and connects to the operator IP services. And it's at that point there, subject to provision of firewalls and carrier grade NAT services, etc., that actually you could be running applications. So, there I can do local offload. I can run applications, right at the cell site essentially if this is deployed that way, or at a hubbing point. But it gives me the ability then to start to look at what else do I need just for a group of cell sites, or for an individual cell site? Maybe it's a rural application where the local town wants to run a website. You could sort of have the city website hung onto a base station as a local service, and you can start to think of other sort of applications that you could actually start to make some revenue gains on. But to say, this is standard 3GPP architecture. There's no proprietary interfaces sitting in here, and it's ready deployable today. The other important point of this is that I can mix my EPC vendors at this point. So I could use a Cisco, Ericsson, Nokia for my core, and then actually I could use a Mavenir at the edge, and to that extent, this opens up and gives some better control in terms of a procurement perspective, in terms of multi-sourcing of EPC functionality and not being constrained by one vendor. So I can end up with lots of small user plane parts of the EPC running against a centralized control plane. So again, helping some of the necessary levers, if you like, in terms of maintaining the cost of a network. Okay, next slide. So if you look at the integrated versus conventional deployment architecture, and this is straight out of one of the 3GPP documents, that if you look at the management and services of an integrated solution, you lose a lot of the benefits that are necessary in terms of deploying this type of an architecture. So clearly today it's not multi-vendor. You can't scale independently the user plane and control plane. Clearly, as you start to think about some of these low latency gaming applications, that you don't have control of some of the other parameters that are sort of needed in 4G and essentially in 5G. But with a CUPS-based architecture, obviously you've got centralized management control still through the SX interface, and I think that's very important that there's recognition of that use of that SX interface. It can be multi-vendor. I can scale the user plane, and I can really put it as close to the end user from an offload perspective as I need. Right, next slide. I think there's a couple of presentation of the slides is getting overlapped, so you may want to walk back, Jason, and back again. Yeah, I think we still got a problem with sort of overlaying a couple of slides. I don't know why, but you'll get the slides certainly afterwards anyway. And in terms of the management of the platforms, again, it's working through the same common management architecture that's been defined within 3GPP, and the ability to offload through the local SGI interface. So if you on the bottom of the slide there, you've got the each cluster in terms of hubbing points effectively, if you like, and then I can bring out the SGI interface for local offload through the SGW, PGW. But from a centralized perspective in terms of management and control, then I can still use all my existing systems to bring that to bear. And and you'll see that on this slide, we heavily rely on sort of the new technologies in terms of NetConf for O&M management in terms of bringing this all together. So it fits with the new MANO systems that are sort of coming into place and existing O&M integration. Next slide. I've still got the problem of overlapping. I'm not sure what's going on here. Anyway, the key point on the next slide here is that as 5G architectures start to roll into place, the split user plane control plane architecture is very, very relevant in terms of some of the service functions that are being defined within the 5G core specifications, and the ability to do new radio standalone and non-standalone to existing EPCs and that. But the whole distributed edge 5G core architecture is very much a decentralized type architecture, which allows you to put these elements at the edge. So how do we pay for this? So if we go on to the next slide. Oh, okay, good. So we're back to a single slide. So this was some work that we had done with Ian Gillett of IGR. This was looking at how bandwidth essentially is going to grow within a single cell site, actually, and we did this at the cell site level, but this can be extrapolated into the complete core of the network. And as data rates grow, new cell sites get put in place. The prediction of bandwidth needed at a single cell site is sort of giving in this top blue line. So moving sort of from today of like 428 megabits per second to almost doubling that in a 4 or 5 year period. And we said, look, if I could just offload the 40% video traffic, which equates to 32% of the total traffic, you end up with the lower blue line being the requirement for data coming out of the cell site. So the assumption here is, on this case, that we've offloaded at the cell site and trying to minimize the amount of traffic going back into the core. And certainly we accept that this offloading could be anywhere in the network. It doesn't have to be at the cell site, but this was just a way to get our arms around how to sort of put the business case together and justification for this. And the result sort of coming out of it is that if I do this, then I can look at saving over 2 years worth of capex opex in my network, because I'm offloading and I'm not having to build larger transport rings. I'm not having to pay for EPC licenses to handle this capacity. But certainly I've got some new investment going in terms of edge servers. If we go to the next slide, we'll see a few of the business cases that we ran on a global basis to say that when we took a real cross section of the world, in terms of high ARPU operators and low ARPU operators over a 5 year period. Sort of coming back to large ARPU operators in the US, savings of after all the expense of peering points, offload hardware, software, I could still save $500 million in terms of actual cost savings in the network. So obviously pays for itself within 1 year period. The same argumentation is applies across that cross section of operators from Europe, Australia, and obviously the low ARPU operators in India, and the operator in India that was there as a reference is about a $500 million saving by putting out these edge servers. And so here not only have you got savings going on in the network, but you've also got the ability to pay for these edge servers that need to go out there. And I think that's been one of the struggles in the industry. Everybody's been talking about these 5G services at the edge, and the first question comes back, okay, what services are going to be profitable? Whereas I think what we're seeing is that you could deploy these types of services to save cost in the network, and then suddenly you've got a platform that you can run additional services on, because these platforms are standard x86 platforms, and can be scaled accordingly to the types of services and the amount of traffic that you sort of want to break out. So, very, very compelling conclusion in terms of the ability to break out traffic. Obviously a lot of discussion about where to break it out, how to break it out, how does that fit within the existing architecture of an operator's network. But essentially, a lot of factors here that, from an engineering perspective, a nice challenge to solve the problem, and with significant savings to be had in doing that. So, that's sort of a summary of one of the applications that virtualization can bring to 4G, don't have to wait for 5G, and using standardized architectures such as the split control plane user plane around the EPC. So I'll hand it back to Jason from that point.
Great, thanks, John. That was a very good presentation. So what I'd say before we move on, and we're just about to wrap up and begin Q&A. So they're having some questions coming in, so thanks for those. And by all means, as we begin to wrap things up, if there are any other questions that you have on your mind that you haven't entered into the Q&A widget, please feel free to do so, and we will get to as many of those as we possibly can. But before that, just to try to put a bow on things before we take questions is, a notion of, we've heard a lot now what to expect next over the next probably 6, 12, 18 months. And, I think there's always an element of here and now when building networks. And a lot of that comes down to, taking care of fundamentals and the blocking and tackling type of analogy. So, I think that, as John just presented, local traffic breakout is one means of supporting near-term ROI models. It's certainly not the only method of supporting an ROI model, but I do think that having these options front and center to help the operator make the business case is obviously extremely important. I think that, the ability to support new services, again, we talked about that a little earlier, but, if we're talking about bread and butter services, it's about making enterprises services better, more agile in support of new business requirements, and as a result, iterative additional revenue streams. And here I'm thinking about, using edge virtualization techniques to help support SD-WAN services in ways of not only serving, Fortune 1000 customers better, but really moving into that middle prize and offering a fuller suite of a robust communication suite to that middle tier of customers or of enterprises that may not have the ability to spend as much as a Fortune 1000. And then, a couple just nuts and bolts things that I hear frequently coming up whenever I'm talking to operators, and one of them is that the VNF footprints still can be somewhat large in terms of the processing requirements and how many cores that they have to run on. There's a lot of desire in the industry to see those footprints become smaller, perhaps break some of the functions into microservices. So if there has to be some optimization done on one aspect of the VNF, you don't necessarily have to change the entire VNF. And then also, similarly, I think, heard a lot about it's as we move into virtualization, and in some ways it becomes easier, some way it becomes more complicated. As we have a particular VNF that might have 3 or 4 suppliers in the ecosystem, testing and diagnostics for the purposes of, doing service assurance can become more difficult and in some ways more complex. So I think those are 2 areas where we're definitely seeing feedback from the operator community requesting, further product development, and obviously that's going to continue to be ongoing. But I think we will see some profound or some meaningful improvements on those over the next 12 to 18 months or so. And then, as we take care of that, I think it moves into the right side of the slide, which is prepping for 5G. A lot of what we talked about today is going to underpin the ability to deploy multi-access edge compute. It's going to be fundamental to the ability to perform network slicing. Obviously going to be key to supporting, enhanced mobile broadband, ultra low latency, and massive IoT use cases. And then also, the idea of matching any access, be it, through a virtual CPE perhaps, to to whatever transport is required and whatever destination it has to go to, whether it's the cloud or the operator or to the mobile core. So those are, I think, some of the things that we can expect next. And with that, we have about 10 minutes left in today's presentation. And so I think that we're just gonna dive right into Q&A. We have several good ones that have come in. And so a lot of these seem aimed at you, John. So I think I'll just probably fire a couple questions your way and get your take on things. And one of the a higher order question, sort of a high level question that came in, I think is an interesting one nevertheless, though, is what traffic do you offload? It says the 40% that's encrypted or the rest or some mix, and maybe how you go about determining that.
Yeah, good question. And the analysis that we showed was really just sort of focused around the 40% encrypted traffic, and we highlight that is because that's the one that clearly from an operator perspective is truly over the top and very difficult to handle. But in reality, there's nothing stopping me in offloading all of that 80% video traffic, and I have the ability, through DPI, through APN addressing, through service addressing, etc., to offload that traffic, and obviously then the cost savings will be even better than we've shown. So again, it sort of comes down to an operator choice. I think the one thing I would highlight is that you probably just look at the top 10 services that are being carried through that network. Facebook, Netflix, Twitter, and providing local connectivity for those will probably affect 70% of the traffic load. So but again, it's choice, and obviously as much as you can offload, the better.
Yeah, absolutely. And kind of a follow-on to that is from a different panelist, but asked basically how that impact, what kind of impact is that going to have on legacy networks as we move from LTE to 5G? Is there a profound shift there, or is it something that operators are kind of well equipped to handle?
I think operators are certainly very well equipped to handle. I think a lot of this sort of comes back into operators having the skill sets essentially to address this. I think clearly we've seen a big shift in over the years of a lot of these services sort of being outsourced and sort of being under the control of 2 or 3 vendors. So the questions have got to be asked in the right way, and the right resources have got to be put around this. But in reality, this architecture, as I tried to highlight, will move between 4G and 5G. You can do this today. You don't have to wait for 5G to come along. In terms of the evolution of 5G, you'll go from what they call the non-standalone type radios, which will use the existing 4G core EPC. So I think it's important to recognize that even under the 5G heading, that using a split user plane control plane architecture with a 4G core is going to be very important for the success of even non-standalone 5G radios, and that's obviously going to be the piece that people are going to roll out first before they can get to essentially complete standalone 5G networks.
Gotcha. Okay. And a couple transport-oriented questions that have come in. So I'll ask the first, and then maybe there's a bit of a part 2 to this. But the first part is, how should we think about the cost of user plane transport in the physical network world? Where do savings come from, and how much is saved for each gigabit of capacity? Is that some? Do you have numbers along those lines?
Yeah, no, I'm going to sort of put some numbers out here. I think there's a philosophical argument that says, look, at the end of the day, I'm carrying the same amount of traffic, whether it be in control plane or user plane, and whether it be in IP or GTP. So in reality, the total bandwidth requirement is potentially the same. It just comes down to how quickly I can get it off my network, and do I have to provide the infrastructure to hub essentially all of this traffic as they do today back into a central node? So you start to see cost savings in the transport equipment to start with, in moving from IP to GTP. Is savings to be had. Then obviously from concentration perspective, the less concentration points I have, again, there's more equipment savings. In terms of sort of the bandwidth on fiber, etc., in terms of the rings, etc., then that bandwidth is going to continue to grow, irrespective. The pipes are still going to be needed to carry this. It really comes down to how quickly I can get it off my pipes and onto somebody else's. Is where the cost savings are really going to start to happen.
Gotcha. And so you kind of bring up an interesting point, and one of the follow-on questions kind of speaks to that is how often do operators need to build bigger transport rings? And, is there obviously there's a constraint of putting more fiber into the ground, right? I mean, that's anytime you have to open up a road, especially in an urban environment, that's a substantial undertaking for an operator. And so in your, what you guys have seen is, number one, what's the pace of these rings filling up? I know that's accelerated greatly over the past 10 years since I was an optical analyst, but then also, are these upgrades actually related to just putting more fiber in the ground or lighting the fiber that's already in there, or is, fixed optical kind of coming into its own?
Yeah, I think clearly when these rings get built or when these transmission systems get built, there's a lot of dark fiber that gets put in the bundle. I think fiber from a physical cost perspective has been cheap, and there's been a lot of spare fiber pairs, if you like, put out there. These will slowly get adopted, but again, it sort of comes back to where's the right point to offload that, and how do I offload it? Some of the other things that Mavenir and the industry has been looking at is how to use new protocols effectively for front haul of radio to minimize bandwidth. So you've got things like Cloud RAN are making a big difference in terms of transmission bandwidth. Other transmission technologies are continually improving, but at the end of the day, to see these sort of numbers doubling year on year in terms of traffic, then there is going to be new capacity that's needed in there, and some of that will be in the operator's long-term business plan, and they will build that, and then use other transmission techniques and other transmission technologies to minimize the usage of that.
Absolutely, good point. And so just, I think we're running a little bit short on time here, so perhaps time for one more question. And I guess this one here is related to just video traffic requirements. And if I'm reading this right, the Netflix, the Hulus of the world, that model is kind of somewhat well established, but now we're seeing more user-generated content, video content especially, entering the network. Does that impact or make offload more cumbersome or complex, or is it really video traffic once it comes off the access?
Yeah, they all sort of get designated in there as a service. It's like Yahoo, Facebook Live, and those types of services. So they can all be sort of classified into a service type category, and then providing you can recognize the headers, etc., then you've got the ability to divert it into the right place. But I heard one example of when an operator launched Facebook Live, for instance, it took down the network for a period because they just didn't have enough capacity in there, and in the core of the network. And so we're going to continue to see this going on, and I think the earlier there's recognition that you just got to get this traffic off the network as quickly as possible, will help protect the quality of the network and the longevity of it.
Yeah, absolutely. Well, I think we're really at the top of the hour here, so great presentation. Thanks to all the attendees for your attention and the questions that you guys submitted. It made for a good discussion, and we certainly appreciate that. And John, I certainly appreciate the time you took to run through this. I thought it was enlightening, and I really appreciate it. So thanks so much.
Great. Thanks, everyone.
All right. Well, that'll wrap it up today. Like I said, the slides will be made available, so please feel free to download. Also, visit the RCR report library for this report that's accompanying this webinar, as well as some of the other drill downs on multi-access edge compute, network slicing, and a lot of other things. And with that, I'll say thank you and have a good day, everybody.